we are starting the second UTC, and one of the things that we changed for this time is to introduce some way of more participative collaboration between the presenters and the people who are watching us. And Jota helped us to prepare this Miro board that has some parts here where you can put your ideas and answer some of the questions, and you could access through this QR code here. You can point your camera and use it, but if you don't feel comfortable using it, you can just put your talks or your questions just in the comment sections, just in the QA here and at Zoom. I don't know if Jota needs to clarify it a little bit more, or if it's okay. It's quite simple to use.
Thank you, Julio. I think that's quite clear. I have also, just to add, I have also added the link to our chat. So you could go to the chat and open the Miro board from the link. And you could put questions to the presenters, you could put information about yourself, and you could also interact with other participants using the board. Thank you.
Thank you, Jota. And well, I think now I will call Monica that will assist us during the presentations, and she will start with some talks to us. Monica, the floor is yours.
Thanks. Could you go to the next presentation? Maybe a slide, also for those at least who joined the previous UTC. But just it's a good starting slide. So saying that we're living in a massive urban age, we are sort of seeing, and also the latest forecast is saying that until 2050 we expect 70% of the global population living in urban areas. But often in this figure, what is not really shown, at least that strong, is that the majority of this growth, the vast majority of this growth, will happening in low and mid-income countries. Also, the vast majority will happening not in the cities we are mainly thinking about, cities like the cities of Sao Paulo or the cities of Mumbai or Nairobi, but particularly in the secondary cities and urbanizing zones where we know very little what is happening there. And maybe just as a conceptual difference between what we are discussing today, so it's a very confusing terminology. So we're talking about slums, and we are very much relating it to the UN Habitat definition, saying a slum household. So it's a household level concept, and a group of slum households form a slum area, versus a more area level understanding, which is informal settlements, which are defined by its sort of irregularity and many other factors. I don't go into details. And this all we are at least labeling often as deprived urban areas, both the slum household level as well as the area level of informal settlements. Next, please. Can you go, Julia, on the next slide? Sorry. Yeah, what we see in many cities, and in a way both, so in high income countries, but as well as particularly in low income countries, is massive urban inequalities. In urban inequalities, which I think is a lot what is in the moment also in the media about crises and conflicts, environmental conditions, but also the urban morphology, which often brings cities which there's hardly any open space, no green spaces for people to interact. But also when we talk about inequalities, I think we need to acknowledge the massive assets, which are often overlooked. Also the self-help assets, like in this case, a community library built in an informal settlement. Next, please. A recent example of this environmental inequalities, and maybe Dennis immediately recognized the area. It's a part of Nairobi, Kibera, one of the largest African informal settlements, deprived areas. And today we're talking about GIS approaches, and I thought it's a nice example where we map together with community groups the location of trash pile, which is a massive environmental issue, not only because of its pollution, but also because of its contribution to floods, because it typically blocks all the drainages, the area getting more and more flooded. But also after a flood, all this waste is happening to flow in the environment, polluting the environment, but also impacting the health of people, particularly of children who are playing in the area, which are massive, have then issues of diseases or waterborne diseases afterwards. Next, please. About conflicts, I could have also put some examples recently from Gaza, which is a similar situation of, in case of conflicts where infrastructure totally breaks down. This is the case of Khartoum, Sudan, which is a bit of a almost forgotten conflict, even though it just started early this year. And if you go to click, then you will see the time series of the night lights, which reflects the access to electricity, but also the access to water supply systems, which are often very much connected with electricity, which typically breaks totally down in a city, is almost disappearing or largely disappearing. But we don't have data about it because we cannot enter those areas in conflict zones. But also in regular cases, particularly the areas we're talking today about, are missing base data about, here in the case of the massive omission of population because of the complex morphologies, but also typically population data at best capture 30% of these areas, often only 5% of the population at the ground. So the missing data is, I think, should be a recurring topic today, hopefully getting new insights about generation of missing data. I think I should stop and hand over to you, Giulio.
Okay, thank you, Monica. Considering this beautiful introduction by Monica, we're going to start to our case studies for today. So we have some presenters, and I will start calling Michael as the first presenter. Michael, sorry, not Michael. I'm following the figure here. I will call Dennis Miwanki for the first presentation. He's a coordinating the spatial activities within UN Habitat Statistic Units. He developed some methodological and data generation initiatives for the spatial human settlement indicators, especially for SDG 11, and have working a lot with monitoring and reporting activities. So just before I give the floor to Dennis, we will start a small clock that probably will appear for all of you in the screen. And we will try to control the time just to have enough time to discussion after all. And you have about 10 minutes for each presentation. So Dennis, the floor is yours, and I will start the clock now.
Thank you very much, Julio. And I'm lucky to be the first one to ensure I keep time. So I will try not to disappoint. Please let me know when you can see my screen. Let me also know if you can hear me well.
Yes, we hear you clearly, Dennis.
Oh, okay, perfect. Yes. Okay, so thank you a lot. Thank you a lot, and it's a great pleasure to be here. I'm going to try to give a very broad overview of the, the slum indicator, but also the new methods that we're proposing to measure it based on the Earth observation approaches. And before that, just to appreciate where we are coming from. Currently, the way we measure SDG 11.1.1, which is on the proportion of population living in slums and informal settlement, we use deprivations at the household level. And here we look at things related to access to water, sanitation, the overcrowding aspects, durability of housing and the locations, tenant security, affordability, accessibility, and cultural adequacy. So analysis that is done at the household level, and we use this to extract information, 3 key elements. One, the elements on slums. The second one is elements on informal settlements, and the third on inadequate housing. And while some of these are area-based requirements, informal settlement, for example, is supposed to be an aerial or physical phenomena-based analysis. Due to limitations in data availability, traditionally we've been able only to measure this at the household level. The new addition to the slum indicator in 2015 with SDGs is the component of inadequate housing. You see in the chart there, it has much more components, 7 components which we aim to measure. But of course, due to data availability issues, we've only been able to isolate one element called on affordability. And we say a household is considered to have housing inadequacy if they are paying more than 30% of the total income, the net income on housing spending on housing. So this method has different limitations and perhaps also limitations on what it means. It means you can be in a very affluent neighborhood, but because you lack the basic qualifiers of adequate housing, like water, sanitation, you can actually be identified as a slum household. So that creates a lot of mix-up and confusion sometimes in terms of what then is a settlement that can be defined as a slum. And the figure here just highlights some analysis done in 2020 where it shows the complexities of you can have a nice neighborhood or a non-deprived neighborhoods where you have a slum also, but sometimes you also have deprived settlement, but you can have inside there, you can also have households which are considered to be non-slum households. So these attributes really translate differently in terms of how we have been able to measure the slum indicator. And some of the issues we've seen is that many data processes do not classify the slum and non-slum measurements. So many times when we want to produce data for the slum indicator, we have to rely on data that is coming in as non-classified data, and we just analyze the household based on the deprivations. But luckily, with the new round of censuses and the 2020 round and also the upcoming 2030 round of censuses, we've seen a lot of geocoding of censuses, and it will be possible to, in future, relate a physical location of a survey to the kind of characteristics that you're able to derive for that from an observation-based analysis. Of course, many of the other surveys that are non-census do not also have these clusters on slum and informal settlements, so it's much more complex to produce reliable data based on that. Of course, we lack a lot of data on the components, tenure security, affordability, but also sometimes even basic components on the durability of housing as well as the materials. So the big question that we've asked ourselves and also countries have asked us over the years is when we say my country or my city, Nairobi here, has 60% of population lives in slums and informal settlements. Where are these slums and informal settlements? Can we really show them where all these informal settlements are? And this partly why we've been working to shift towards a more geospatial-based analysis of the slum indicator. And what we want to achieve are about 3 or 4 main things. First thing, we want to, or we've been working to towards an approach and a model that can be scaled up and adjusted to different contexts to reflect consistently characteristics that depict an area to have the traits or qualifiers of an informal settlement as a settlement in this context. So moving a bit from looking at the households in the settlement to really looking at entire settlements. Then inside the settlements, you also want to distinguish if we process this at the city level and analyze and see what are the distributions of informal areas in the city, from very small areas, which could be pockets, small pockets within neighborhoods, to entire neighborhoods, to also the entire city analysis. We also want to be able to see, to zoom in and see within an individual neighborhood, what are the variations in the deprivations? And this, we've tagged it slum severities. We can have severities of different slums in the same city, where you have one slum which is worse than another, but you can also have within the same settlement areas that are way worse off than others. So for us, the issue of the scale is important, and the intention is really to ensure that these models get scalable or can be scaled from the smallest unit to also the entire city level. And here just showing that we also, the objective also to ensure that we capture the diversity of manifestations of informalities across cities and countries. And Monica and team through the joint project have been really doing a great job of building from bottom up, but also looking at top-bottom models. The second thing that we are considering beyond just looking at geomorphological aspects coming from Earth observation is the element of integrating the geospatial information with socioeconomic data, but also data coming in from communities, which traditionally has been one of the big challenges of getting data coming from communities into formal data processes. So the objective of this work we're doing is also to really ensure that this happens. And the third thing we want to do is, of course, to ensure that we can be able to look at a place over time and say, due to interventions, this is what this place was before, which is very possible, of course, from remote sensing, and see after intervention in a certain year over a certain period, this is then the changes that have been achieved in this place. It becomes very easy to track the impact of processes at the local level. But of course, we'll use this to co-validate a lot of the slum data that we've been producing over the years, as well as also to enhance how we estimate populations living in slum and informal settlements, but also additional elements on people who are vulnerable to different sorts of disasters at the local city level. And then ideally also to narrow down to specific areas of intervention. And one of the image at the bottom there that shows, if you look at this place in Nairobi, if you look at it from a remote sensing perspective, you can actually see the differences between one part of the road, one side of the road that is really deprived, or rather the settlement is a very poor quality, to a place that is improved incrementally by the local communities. So in this case, we are able to really see what kind of interventions can be done at the local level. So here, just to conclude and summarize, this what we've been aiming to do and working, of course, with partners is we want to have this model hopefully as part of the next series of monitoring of slum indicator post 2025. And we've seen a lot of advancements in the technologies, but also the available data to be able for us to apply this at the different scales that we need the analysis to be done. And we've seen also a lot of contributions of communities into this kind of data processing and monitoring. And more significantly, one of the key things that has also happened in the last 10 years or so is a lot of adaptability of geospatial data. Traditionally, it's been a bit difficult to integrate geospatial data fully into monitoring processes. But as you notice, a lot, many of us who are involved in the SDGs, is that we are having a lot of indicators that are purely being monitored now based on our observation methods. So we're leveraging this to say, since we've already advanced so much and countries have accepted this as an alternative method, then it's an opportunity for us also to enhance towards that direction. And of course, the other thing we're saying is slums should not also be viewed alone. And having statistics on slums without really understanding the relations between one area to the next one that's surrounding, then we really don't get the bigger picture. And of course, this for us, the emphasis is that as we use remote sensing and other observation-based analysis, we can actually relate a lot of the information on the ground and be able to contextualize intervention and also understand urbanization from a larger perspective. Finally, and great news is that there's a lot of renewed focus on the housing and slum transformation discussions. And one of the key resolutions from the UN Habitat Assembly is a reaffirmation of the role of slums and the work of UN Habitat and partners to support the transformation of slums and informal settlements, with a resolution that seeks to accelerate transformation of informal settlements. And one of the main components is actually data. And it proposes that we need to improve our methods for understanding informality in a manner that is much more accurate and reflect the true situation. So already this has created the platform for what the work we are doing just beyond the SDGs, but also post 2030, because the work of housing continues to be at the center of the focus of the Habitat and partners. So I'll stop here and thank you. Hopefully, we continue to partner and have the discussions on this topic.
So thank you, Dennis. Great presentation. Thank you for staying on the time and the planning time, right in the time. Let's move to our next presenter. I will just share my screen again to present her. Let's find here. Okay. So our next presenter is Professor Flávia Feitosa. He's working based on the Federal University of ABC in the São Paulo state. She works with the development of innovative analytical frameworks based on innovative methods and data to enhance the understanding of health situation in Brazil. He combined several different approaches to it and trying to fill the gap in the areas that we don't know exactly where the slums are in Brazil. So now I'm going to invite Flavia to present. Flavia, the floor is yours.
Flavia, you muted.
Yes, now you can hear. Okay, so thank you very much. It's a great pleasure to be here, and I'm going to share some of our experiences mapping
Flavia,
informal set.
You're sharing your Gmail.
Oh my God, sorry. Wait, you share. No, that was not my purpose. Fortunately, there were nothing. Okay, now it's good. So now again, thank you very much. And thank you for warning me that I was sharing my Gmail. So now I will finally share our experience with this, developing these methodologies for mapping informal settlements within a Brazilian context. So when I'm talking about a Brazilian context, we are talking about a country that it's well known for the prevalence of informal settlements. Even the word favela is recognized worldwide. We don't need to translate it anymore. And of course, the living condition in the settlements is a major concern for public policies. And one of the many challenges to address this issue is the persistent lack of quality information. We are all here about it. But we are fortunate somehow, because in Brazil, we do have official data sets on informal settlements that are provided by IBGE, or National Statistics Bureau, but also this data underestimates the prevalence of this settlement, and several initiatives have been conducted, including classification models, local service. And one of the critical challenges for these initiatives and also for IBGE survey is the diversity of the settlements, as Dennis also pointed out. We have so many forms, so many shapes. Very often we don't know how they look like. Sometimes we don't know what we are actually attempting to map. We don't find a consensus on that. Just to bring some examples, in a project we had in a small area, which is Baixada Santista, the coast of São Paulo, we could see there, we could classify typologies such as hills, such as stilt house, wetlands, other disordered occupations, also occupations that are ordered with a regular layout or with a very low density, sparse and poorly consolidated. And this I'm talking about one small region for Brazilian standards, of course. But when we scale this to the whole country, then it's really overwhelming. We cannot even find consensus on how to name these settlements. Favela is only one of the many names. And so having this in mind, I will present some of the results of the NUI project. NUI stands for Núcleos Urbanos Informais in Portuguese, informal urban settlements, which was a project that answers, it's a response for a demand of the National Housing Secretariat, and it was coordinated by the Institute for Applied Economic Research, IPEA. And this project covered 6 different regions in Brazil in very different places, so trying to represent some of this diversity in different biomes with 157 municipalities. And one of the work packages was intending to generate models that could create probability surface regarding this presence of informal settlements. And the creation of variables for this project, that was a huge chapter. We could spend hours here because there were so many different types of variables. Then we are trying to collect and organize, process variables that could be potentially relevant for the identification of informal settlements from several sources, some more traditional, although outdated, like census data, but also trying to explore more sources with constant updates, including, of course, remote sensing, OpenStreetMap, but also administrative register that was something new for us, and sources that would be available for the whole country, because the idea was to extend this approach. Here are only some examples of variables built from OpenStreetMap, coverage of roads, the shape of blocks or pockets of occupation with shape index, or geocoding these administrative registers. This is CadÚnico. It's a register for families that are engaged in social programs. So here we have the density of registered families with unfinished or unplastered exterior wall in the residence, which in some place, like as I said, Brazil is diverse, can give us, for instance, some hints of where these settlements are. And we integrated all this data in a cellular grid with 100 meters. We had about 160 variables. And then we built this probability surface. We used the official data from IBGE, this of informal settlements, as reference, as samples of these informal settlements, which are here represented in black polygons. And here we have the probability surface. Darker areas are those with higher probability of having an informal settlements. And then here we see dark area here, dark areas here. And then comparing with the information from survey data, which was another front of the project, we could see that some of these were actually locally identified as informal settlements. And here are some more examples in Belo Horizonte also, the official data in black and the probability surface pointing out that there were other places that were somehow similar to the samples. And here the result of the survey data on informal settlements. Here an example from Northeast Brazil, from Recife. Also the official polygons, the probability surfaces, and afterwards the field work that were going in parallel. But as you see here, the probability surface may give us a hint, but also has some mistakes. So that's why it's important to point out, like here, this is not an informal settlement, although it's very red, very dark, high probability. So that's why it's important to mention that we understand this probability surface as only an additional layer of information which complements other information on informal settlements. So the idea is that the convergence of these different layers, information, or the divergency, could lead us to lower or higher uncertainty about the presence of informal settlements. And it's very important, especially in this case of divergency, it's very important that we are able to explain and to interpret this model. That's why I'm highlighting here the need for investments in the interpretability of models. In the surfaces I presented so far, we used very simple classification strategies. We used logistic regression. It's relatively simple to interpret. But we have a diverse reality, so we don't need more complex models, but they can't be mysterious models, right? So we needed to invest in the interpretability of these models, to go more into interpretability methods like this shape values, which indicate how each feature is contributing to the model. Here are examples produced by colleagues with this data set from XGBoost models, where you can make local analysis. So why this area is showing that has a high probability of being an informal settlement, and show how each feature is contributing for that, like income or density. And also global analysis, what features are contributing the most with the models and with which values. We see some features that are somehow regular, high density, has high contribution, but others not, like shape index. Sometimes they have high contribution, but the values of shape index is low, and so on. So try to combine this local and global analysis, invest more in interpretability is quite important if you really want to facilitate communication and bridge the gap in conveying results to multiple stakeholders that are engaged and must be engaged in this mapping process, and also to contribute to reveal the diversity of informal settlements. So we need to understand what the models are showing. So helping us to really represent this multifaceted nature of the informal settlements. So the results I presented here is the work of many people. I mentioned some of them here. And finally, I would like to thank you very much for the attention.
Thank you, Flavia. Thank you for presentation, wonderful. So let's move on to our next presenter. I will just share again my screen, then we can take a look. Okay. So moving on, we have Sophie Naue and Michael Hawthorne. Sorry if I'm mispronouncing it. You can correct me later. And both Sophie and Michael, they work at the scientific innovation space. They are working at the United Nations Technology Accelerator for Cities, with, as I know it as UNITEC. I don't know if Sophie is present or not, but I know Michael is here, who is going to present it.
Yeah, actually, Julio, I'm present here.
Oh, okay.
Unfortunately, Michael, my colleague, is ill today, so I will cover his part of the presentation. So, yeah.
So, yeah, I'm giving you the word. You can go ahead. Thank you.
Okay, thank you, Julio. Please let me know when my screen, my presentation is visible. And yeah, 1 second. I think it should be now in presentation mode, right?
All good. You can go ahead.
Okay, thank you. Okay, I'm happy to be here and present on one of our first pilot projects we developed on behalf of UNITEC, which is the BEAM tool, the Building and Establishment Automated Mapper, a tool that uses AI to detect informal settlements. But first of all, I would like to say a few words about UNITEC, the UN Innovation Technology Accelerator, where I'm working. So UNITEC is a partnership between the United Nations Human Settlement Program, UN Habitat, the UN Office for Communication, Information and Technology, or ICT in New York, and the Hafen City University, where I'm based and where our lab is as well based next to the City Science Lab. So we are quite young partnership, got seed funding from the German Ministry of Foreign Affairs, and we are as well part of the People-Centered Smart City Flagship Program from UN Habitat. And what we do is we work with data and cities. We support local and national governments in their digital transition. We do this with a pretty much applied approach. We use mapping, spatial analysis, and data visualization, and we work here together with programmers to develop tools and digital applications to use data in different ways to do to support integrated urban planning and basic service delivery in different countries. Yeah, I just would like to share one slide with a few impressions on our lab here in Hamburg, so our ecosystem and lab culture. So UNITEC is a multidisciplinary team of data scientists, programmers, urbanists, and our research and action field is the digital city. We believe in an agile development of digital tools and systems, and we follow here a multi-stakeholder approach to co-design the city together with a variety of different stakeholders. And so we are an experimental space for applied research. And yeah, we do applications beyond prototyping. What I will show you today, our tool is more a prototype right now, but probably getting into different application. So in our sister lab, the City Science Lab, we do build different interactive tools, cityscopes to foster collaboration. This is just an overview of tools that we have. I will not go into detail because I would like to focus on an interactive mapping and AI-based approach that we developed for the city of eThekwini in South Africa. So actually, this was one of the first pilot projects we developed on behalf of UNITAG, together with the Human Settlement Department in eThekwini as our partner. And here the idea was to use AI, machine learning, to accelerate the mapping of informal settlements on aerial images. So we developed a tool for city planners that uses AI and maps the rooftops of informal settlements. So we wanted to support the city to automate their land mapping processes and to accelerate and improve their data accessibility. So what you can see here on the slide, moving is actually already the output of the tool. These are shapefiles with the rooftops mapped. And but first of all, I would like to, before I go into detail into the tool, provide you with some background information in the case of eThekwini. So as you know from a lot of different cities around the world, the city of eThekwini has 25% of its population living in informal settlements. That means more than 580 informal settlements in the city. And in order to develop a pipeline of urban upgrading and basic urban service delivery projects, it's essential that the city has access to evidence-based information and an idea of a number of location and informal settlements. So there were quite a few challenges of mapping informal settlements, because mapping informal settlements is a very time-consuming process. It often involves manual digitalization of aerial images, on-the-ground surveys. These are very important points I think we cannot cover with AI. But in case of eThekwini, we had 15 on-the-ground land monitors, and land monitors cannot keep track of the fast changes in the informal settlement development. So that leads to often outdated records on informal settlements and makes it difficult to plan upgrading interventions in an appropriated way. So this was just the initial point where we started to develop the BEAM tool together with the Human Settlement Department. So here the idea was to improve data accessibility in eThekwini on informal settlements and to use machine learning. So with UNITAG, we developed the BEAM tool, and the BEAM tool was developed as an easy-to-use tool that allows the user to quickly detect and visualize footprints of a specific area. So by uploading aerial images, so through 4 simple steps, BEAM provides some prediction of informal settlements in a given image or area. So you select an input folder with your images. You select as a second option a model that we developed, and you select an output folder where you want to store your images, and then you run the building detection. So that's quite simple, but what the tool then does is it marks all pixels that are or that the model is trained to recognize as informal settlements. So for now, it's not only picking up informal settlements, so it's trained on rooftop material, on size of buildings, and it provides the city with GIS layers where informal structures are marked. So you can open those shapefiles then in QGIS and work with those further. To get so far, we had to face a few training challenges. So just to mention some of them, so accuracy on the edges in the beginning was sometimes lower. The model marked overlapping structures as one, as you can see on this image where these green overlapping structures are marked. Sometimes large buses get picked up as buildings. Part of buildings in the shade of trees does not get picked up. So we could train the model to get an accuracy of 94%. So if we could solve a few of those challenges for the city of Itiquini. And my colleague Mike has actually worked or has done his research and revision of this training process. He created new training data in the second phase of the project, supplementing our data with open source data to improve accuracy of the model. And he has tested different images as well, different years. And but I will not go into detail into his research because he is the expert on that. Just focusing on the outcomes and achievements. So with the BEAM tool, we were able to automate and accelerate mapping processes and to make workflows from the GIS department more efficient. So we are able to map the whole city of Itiquini in 72 hours. We did that once with our data scientists here, though. That means one image in 70 to 90 seconds. It's quite fast. We are able to do a work that otherwise would have taken months on the whole project team. So, and we are just starting a second phase with the project team in Itiquini to provide better accuracy and to be able to train the model further, not only on aerial images as well on satellite images. What was super important for us in this project was to co-design this tool together with our project partners in Itiquini. On one hand, to correspond to their needs and as well to hand over the tool to them because it needs to be trained on different images each year again. This is then a little bit easier than in the initial phase. So the city of Itiquini and the GIS department has direct access from the municipality. So we could advocate local ownership to the tool. We provide them with a step-by-step guidance on how to install and run the tool. We had several tech sessions on that, and happy that we got feedback from Itiquini and that we can enter with this project with them in a second phase, using the tool as well to map CBD area and industrial areas. So it's going to be trained on that. So my last slide, I just want to mention that we have a different ideas to upscale the tool and to develop it further and to implement it in different countries. We just started last week a new project in collaboration with UN Habitat Mexico to do an inventory of informal settlements in Central America, or more precisely on 8 Central American capitals and Dominican Republic. So here we are training the tool on satellite images. It's now trained on aerial images, so it's instead of aerial image, satellite images, and to provide an overview of number, location, and principal morphologic characteristics of informal settlements in South Africa. Yes, we have as well further ideas to train the tool further, or to use or combine the tool with census data, to combine it with community mapping, and more bottom-up data and a more participatory approach. This will start in the second phase. So for now, thank you very much for your attention. And if you are interested to know more about the project, we have a project story on our UNITAC website, and happy to discuss with you further. Thank you. I will stop sharing.
Thank you so much, Sophie. Actually, I'm a fan of BEAM since the first time I saw it. I have few questions myself, but I will save it for the round table. So let's move on to our last presenters. I will share again. Sorry, just 1 minute here. So just to finish our round of presenters, I will invite Angela and Pere. And Angela is actually, she's working now in the University of Glasgow and also at ITC, University of Twente, and inside the Idea Maps project with different approaches in slum mapping also, and now more related to Sub-Saharan Africa projects. She's working on it. And Pere is a specialist in web developing geospatial tools for web, and he has worked on several different projects in this field since then. So now I would like to invite Angela and Pere. So the floor is yours.
Thank you. I think I'm going to be presenting, and if something is needed, Pere will also jump here. Okay, I'm gonna spare my whole screen. Can you see my screen? Let me hide it. Okay, perfect. So I'm gonna show you today a project that we developed, the University of Twente, UTC, together with the University Free of Brussels in Belgium. The project name is Slums, and this was founded 2 years ago by Belspo, and this was a 3-year project. So, well, it's a Slums, an innovative data portal to EU-based infra-slum data. Today, I'm only going to show you what is the portal and which kind of data can you pick here. But I'm not going to go so deep into all the techniques because, well, I want to show you a little bit where you can find more information. Well, within Slums, we faced the problem that we didn't have. I think all of the presenters before, no, we highlight that we face, like, we don't have information or data in these slum areas, and there are also the data that we have. They are very uncertain. So how can we map this we came with this research question: how can we map this intra-urban characterization towards scalability and transferability? And we have different study cases in Sub-Saharan Africa. The methods we use for most of the projects were remote sensing, artificial intelligence, but also a huge component of citizen science, collaborating with the people living in the slums. So yeah, I think the first presenter, Flavia, or the second, also state that this huge variability that we were facing. This is only within the city of Nairobi, this city that also shows quite of differences. So how can we not only map the area which are yes or no informal layout or informal settlements, but how can we really also characterize intra-urban characterization? And for it, we came to which aggregation level. If we want to compare, we want to unravel these differences within the urban cities. So we came that we need to go a little bit apart from these administrative boundaries because they are not comparable, and we need to go to a more physiognomical area, and to also preserve ethics. We decided that the grid could be regular, and could we integrate it in other also data sets, and could also preserve privacy. As I mentioned before, we were very concerned of how can we escalate this project and how we can transfer it to different across countries and across different cities. So we try to experiment as far as possible with also open free satellite imagery, but of course some of the projects has been done with a very high resolution that is high cost. The project could afford it, but and also have better, more detailed information. As I say, this project also has been collaborating with in some of the projects of some of the different data sets, as you will see, with more than 200 participants from the different slums areas that also give a lot of local insights to the projects. I also put the link here in the chat. If you want to see the publications, you can see here, in the portal of Slum Map, you can see a more descriptive and all the papers, also the link to all the papers. And let's go today to this. That is the web that we have developed, the portal with different cities. So here you have the link. I already put it in the chat, and I will jump there. I will try to, okay. Sorry, with this, and I'm going directly to the portal. So we are here, and I'm gonna go to the example of Nairobi because also Dennis before he talked about it, and I think it will be interesting to maybe also for him maybe to hear that. So you can click. Well, maybe let me go again. We have here a little bit of a description. What are we doing? We are mapping at different scales. So we have a city-wide scale indicators, but also then we go within the deprived areas, and then we extract more indicators. And what is important here is also different websites or different projects we have been collaborating. So it's not only Slum Map, but this is Onekana, that is the continuation of the Slum Map, the same people we are working there, and we are now developing new indicators. Here you can meet the team, and Per, as before has been introduced, has been the one that has developed this website using open source. And if there is any question or query related to the website, please, he will be the expert here. And well, here also you have a little bit of the reference. So then we go to the city we want to study. And yeah, here you can see the city. And here we can, of course, change the base layer. I think that's also very common in all the different websites we have nowadays. And here, if you switch here on, then you can see different indicators here in the change map that we have mapped at the citywide scale. So we have morphological deprivation probability based on model with Sentinel-1 and 2, others, and also the approach model with open buildings, and compute from Google, and others building fractions, so how many proportion of buildings do we have in within the grid. Then different density, population density. This is from data for Good at Meta, but also from SDI and other sources or other portals. So we have also not only produced data, but also integrate existing open sources that we found relevant. When you, for example, let's go to this deprivation probability, you can always switch off and on from here to see the specific group that you want to hide. For example, if we go, we can also the opacity change it, and you see here you can see a little bit of the statistics at the city scale of the different groups. If you click on it, you also can see how the different indicators are performing here in this specific grid. You can, from here, download if you want the statistics, for example, download PNG or in different formats. So you can also have this chart download this chart. Well, let's do it so you can see it a little bit in a bigger scale. Yeah, this is, as I say, at the city scale. And also here, I'm not going to do it because it's going to take a little bit of time, but you can download all this map, all this grid with all this information, also with metadata on it. Also, the web allows us to change the color schema. So you can change it here, for example, and also filter and have it different values, different ranges, if you want to specifically see something different. We can go now to the other, this within the private areas, as I say, the other was at the city scale. So here you can see also the aggregated at the grid, and we can see different indicators. Here we have a lot of different indicators, and each of them represents road index, the distances, accessibility, vegetation, shadows, vehicles, how many, count of vehicles. All of them also here in parentheses, you can see a little bit of a little descriptions because we didn't want to put too much here, just when you download the information to have a complete understanding. And you can go through a lot of them. For example, this one is something that I'm really also happy about. It is the perception of the people. So people has been labeling where is the best place to live within these deprived areas. So we have like where are the worst place to live, and we can go close to it, to see the differences between a better area or a worst area based on, for example, this is one of the worst areas based on the participants' insights. Yes, as well, you can here download the chart, and you can change here the color. And lastly, I don't know the time because I cannot see here, but I hope I am on time. Here we have done also within the deprived areas, the land cover. So here is active, that's why we put it apart. But well, you can see the different, we have modeled this in WorkView 3. So you can see here the different classes. So building class, ground bare class, low vegetation, trees, the shadow, the vehicles, also the waste piles. So you can try to understand how is the space, and you can interact with the data before downloading it, and and have a better understanding of the city. So that's all for me.
It was great. Thank you, Angela. It was wonderful, lovely. I'm impressed how brave you are, just clicking all the parts of the map, because based on my self experience producing this kind of user's interface, and yours working perfectly, very fast. I'm kind of impressed. It's working very well. It's not the way it worked for me all the time. So I think we are reached the end of our presenters, and now we're going to move to our next step, that is the roundtable. But before it, I just want to thank again for Rota for the brilliant idea of making the mural. I just took a look on that, and it's full of colors and full of words and everything. I think it's really working. Thank you again, Rota. And well, very different presentations, all complementary, from recognizing the role and importance of data to understand the slums and to taking actions to improve it, as Dennis put it on, and from applying gridded models and probability surface, like Flavia told us, and how he combined different stuff, and she's showing how some of the Brazilian slums are not appearing in the map yet, even we have this huge amount of data. And in the case of being much more complex approaches using artificial intelligence, I don't know if it's deep learning or not, but I'm going to ask soon. And in a way that we can tailor it for the local context. I know it's you can apply in a world globally all the places in the world, but you can tailor it depending on your needs in the local context. And like in the last presentation by Angela, showing us how the importance of how to access the data and how we can use the data in a way that anyone can just look at the data and access and download it. It's working beautifully. So I will just move to the next step. I will just share it again. Sorry, 1 minute here. I'm the one who is messing up the time now. But it's gonna work. Sorry. Here. So now we have a planned roundtable with some guest experts that are present on here on the Zoom link. But anyone in the room can chat with us, can put your questions, use the mural board, or just use the word. So we have Henry, so if I'm mistaking the names, please forgive me. Henry Bulley from the Bureau of Manhattan Community College in New York, Matches van Ostrom for Habitat, Mutoka Mbati Mussini from the University of Nairobi, Elio Villaseñor and Andrea Ramirez Santiago from INEGI in Mexico, I think. I'm sure it's Mexico. Juan Pablo Espina Zapata from Colombia, Universidad IAFIT. And Hayan, I don't know if Hayan is present, but Hayan is a Brazilian guy, but it's working at the UTC, University of 220. There's some other names here that are now gonna appear.
No, Binti couldn't join because of the time difference. So I still acknowledge.
No, you can go ahead, Monica. I was just about to call you.
No, great. So maybe if all the roundtable discussants could also turn on and just leave the slide, please. You stop sharing if everybody of the roundtable discussant and the presenter, if you're okay, turning on again the question, your camera. And thanks for the introduction. So I think it would be now nice to talk about, we have heard a lot, but mainly to talk about the questions. So after listening to the presentations, before we now jump to the questions of the audience, and I go maybe one by one. So what type of informal settlement related data are most needed? What are typically really the challenges you face getting this data, and what tools you found most interesting, either hearing today or from your work? And I will simply go order by order, and I would like to ask each of you, the first, Henry, you're free to pick up a question you like most, and then I will sort of in the end will allocate questions if you haven't been answering.
Yeah, thank you very much. I really appreciate the presentations I have been made so far. But one common thing that I picked up from Dennis in the first presentation, coming down to the last presenter, Angela, was the scale of analysis. Because Dennis talked about scalable, and then coming down to Angela, she had data sets that are coming from different data sources, but they seem integrated. So one of the questions I have is, how do they address the different scale of the different data sets that they are integrating into some of these mapping?
So I think it was a direct question to Dennis, correct? So maybe Dennis, would you like to respond? Did I misunderstand, Henry?
Yeah, to Dennis, a little bit to Angela, but mostly Dennis.
Thanks a lot, Henry. So for us, the intention is to ensure that the units of analysis can be scaled down, but also scaled up. So the most preferred option, of course, is to try and work at the grid level, but sometimes also at the block level. We've tried approaches where we do strict block level analysis, which can then be built up to the city scale, but also you can build it also up to sub-settlement and settlement levels. So the intention is for the information to really be scalable. Then with the emphasis is that having small scale analysis of one settlement in a city is not as impactful, at least for the work of Bien Habitat, is when we talk about the slum indicator, it's not as impactful as when you can actually analyze the entire city and multiple cities at the same time. But with a lot of the things also colleagues are presenting, the idea also seems to be the same, more or less, to have a unit of analysis where you can come from settlement level and this information gets built up to be able to do city level analysis.
Great, thanks a lot.
Thank you very much.
Maybe also I want to point a little bit, like just a little, that when we have a lower resolution, so we have lower than the grid, it's easy to aggregate it. But sometimes we found data sets that they are bigger, no? Like for example, beers, no, about light or others kind of data sets that for us also is very important is uncertainty. So if we are not sure what we are mapping or like the information is quite uncertain, for us also we give a little bit of an understanding first before uploading. And I think it's very relevant, no, to understand the scale we are working, to be able to understand which uncertainties, no, what are we missing if we bring data sets from a coarser resolution. Yeah. Okay.
Good point. Thank you very much, Angela. That's what I was trying to drive at.
Oh, thanks. Maybe I would like to give next the floor to Matthias van Ostrom, if he's you does. So please pick a question and maybe if you like to direct it to one of the presenters.
Oh, that's a difficult one. I won't direct it to Dennis because we can catch up later. But no, yeah, thanks very much for having me. I work at UN Habitat on the same floor as Dennis. No, I was just listening to all the presentations. It's quite interesting. I had a question in my mind. It relates very much to climate change and the interface with informal settlements. I don't think I've heard any of the presenters mention the words climate change. So for us, that's a really big data gap. I mean, sure, we need to find out where informal settlements are and what different types there are in different places. And I think that's always a necessary, let's say, first step. But then the really interesting question is, how does this then interface with all kinds of other things? Whether that's sea level rise, whether that's exposure to flooding, whether that's heat stress. So having the link also between climate data and informal settlement data, and then having that interface in terms of which areas are most exposed, which settlements may have more capacity to adapt or respond, which ones are most vulnerable, combining with population data perhaps in terms of where the most people live, perhaps even linking, where do investments need to be made. So you can make some kind of cost-benefit analysis, even though you're talking sometimes about people's lives can be quite difficult. But this whole interface is really quite I think, a big data gap. So we would be quite interested also to work on that more. And I would be interested to really any of the presenters also to think about whether you've engaged with that in your own work or whether you see opportunities using your own methodologies and data sets and combining it with data sets on climate change. So yeah, really open to anyone. I already see 2 people or 3 people with their hands up, so perhaps they'll respond to this or not. I'm not sure. Thank you.
Maybe if I may be a bit authoritarian, I know that some people have their hands up and I will come to them, I'm sorry. But maybe Flavia, you would like to respond to the question, because I think Brazil has maybe a very fruitful ground to this question.
Yeah, it's not an issue that we have worked directly, but we have some experience, for instance, with measuring urban heat islands in 2 different cities like São Paulo and Delhi. It's a student, Rohit, who was studying here, and how this is correlated or not with the presence of informal settlements. And we found was that, yes, we could find a coincidence of these places as being the most vulnerable to heat, but we still have lots of things to do, like to try to understand which kind of informal settlements typologies are, like you mentioned, more vulnerable. We do have a particular typology in places like São Paulo. We have favelas that are more and more vertical. We have a favela made of buildings and no space anymore, which made it very difficult from the point of comfort, right? I mean, so that's, especially here where I am, the metropolitan region of São Paulo, is a particular issue. But of course, and regarding hydrological events, then this is definitely a space for lots of discussion. We see many disasters every day. You already know that they will happen. They did already happen before, but now with climate change, it's just getting worse and worse. So I would say that in Brazil, the main hazards we do have are related to this hydrological events. These have been our main concerns here, and of course, target of public, it's a concern of public interventions and so on, but it's as long as we don't deal with inequality and the housing issue itself, we can now not find a pathway out of it. So it's, as long as people don't have a place to live, it's what happened and tends to continue, right? I mean, it's getting worse and worse, and we have recent events right now and very sad.
No, very clear, thanks. Angela, would you like to
But I think Celine has the hand before me, so maybe Celine can come and then myself.
Yeah, we in the moment just having the first round of responding from the roundtable to the question, and I will open then for the
Sorry.
Yes.
I thought you didn't see her. That's why I was just bringing her. But yes, indeed, I wanted just to bring very little because I didn't have time before and I couldn't express. But now we are currently with a founded project called Onekana that we are also gonna include in this web portal in the near future. So we are now addressing that climate change, how it's affecting the population in the city scale, but also within the private areas. And we are measuring heat. And also we have the same results as Flavia, like we saw that there are, from the land surface temperature, they had the heater, on the slums area are the hottest one, but also at night they are the colder. So that means they have the lesser, as you say, building, the adaptation of the buildings are quite low. So we are on it and we are very concerned, and also for them, we have several discussions with the people living there, and for them it's also a big concern. Also, we are mapping pollution, and yeah, we will maybe next year put all these outputs into the portal.
Thanks. Maybe if I can go to Musibi, who's also from Nairobi. So maybe I can ask you, what do you see the major data gap?
Thank you.
Yes, go ahead.
Okay.
Please.
Thank you, Monica, and all the presenters. This is amazing, and I will just quickly go back to your opening statement that by the year 2050, it is true that the greatest global population increase will be in low and middle income countries. I perfectly agree with you. So that takes me now to today in the year 2023. We should be thinking about what approaches will give us the best options in terms of understanding and getting more accurate data in a cost-effective way within our settlements. That is a big question that we need to answer before the year 2030. And thank you, Sophie, and everybody in the team for that good work that you're doing. But please understand this. Yes, when we use all these methodologies, including artificial intelligence, Earth observation, etc., that is a very good picture about what the slum is or where it is. But there's a little bit more about what really a slum is all about, because it is about the people, the spaces, and activities. When you go out there and use artificial intelligence or Earth observation, there's one critical aspect that must be thought through and given a lot of weight. The people, the spaces, and the activities. Then going back to your question, what is the most important data? Yes, the where question has been answered very well, but please, we want to provide services and infrastructure to the people living in the settlements. So can artificial intelligence, can Earth observation help me? Maybe 30, 40%. So we always need to complement what we are doing with the human face, the human aspect in informal settlement mapping. This is critical, and it will take us to beyond what we can actually see, because we are moving from what we can see to understanding and taking decisions. Otherwise, we will be in the danger of producing good information, but not usable. This is very scary that sometimes you can come up with very good information, not very usable, because it did not tell me how many people need water, how many people are affected by XYZ diseases, I don't know. And that now becomes waste. So moving from research waste to having research and data and outcomes that have real impact on the people living on the ground, I think is a very good way to go. And that now takes me to something I thought through in the last 1 month about big data. Yes, we are thinking about the future. Yes, absolutely. We have mapped the slums, number one, but I think also economists are also monitoring the space, how countries are growing, how they are not growing economically and otherwise. So we can combine urban growth, slum development, economic development, and population growth. That is a lot of data, but it can make a lot of sense to us. How then, I'm going back to the first question, that 90% of population growth increase will be taking place in the low and middle income countries. Fair enough. So with the big data approach, we can very easily say this growth is taking place or is likely to take place with this number of people being in slum or non-slum. And then as a decision maker, I can quickly now decide what resources in future do I put to address that situation. So this is very interesting. From one end, getting very accurate spatial data, on the other end, getting good or accurate economic data and also population growth data. This happens periodically across all the countries in the world, and we are now getting into very useful space, having a big data approach where economists, social scientists are speaking with spatial scientists. Thank you.
Well, thanks a lot. And really the call for not only data, but also solutions, I believe very much my heart is there. Maybe, I don't know, maybe Andrea from Iniche, would you like to respond to the call from Musimi about how to translate data to solutions? Are you with us, Andrea?
Hello, Monica.
Good morning, Andrea.
Good morning. How traduce data solutions?
How to translate data to solutions to improvements? Because I know that you work on a national scale, and maybe you can just say first from where you are, and then from which perspective you take the question how to translate data to solutions.
Okay, well, in the case of Mexico, the proposed methodologies allows the integration of diverse data sets towards using a data lake architecture developed by INEGI and a grid-based approach to build an ecosystem of interoperable information with an interactive use interface. The open source technology also offers spatial scalability, transferability, and flexibility to work with different data sources, while the grid-based design can facilitate the exploration of integration among variables. Moreover, the dataset used for this work are open and freely available, granting replicability. But in the case of the air observation, or in the case of pilot of Mexico, for Mexico City does not yet contain air observation data. My question is will be for Flavia, and what would be recommended for approach to successfully integrate air observation?
Okay, thanks a lot.
Can I
Flavia.
Can I answer? Okay. Also connected with the previous comment, here the works we do, they are always, let's say, provoked. They are always in response by planning institution. And one of the things, it's actually also related to the first question. One of the problems we have here, so a planning institution usually relies, let's say, on indicators, want to know how many people without water, how many people, how is the density inside the housing unit, the cost of the housing, and all those important dimensions that represent the housing needs. One of the issues we have here, and it's very serious, is that this data is in different scales, right? So we do have a very nice survey that brings these indicators for us. So we have these indicators for housing deficit and housing inadequacy, it's how we call it, but they don't fit with local data. This data is for municipalities. So one of the challenges we do have here, it's like we do have the indicators, but we don't know if they are inside or outside precarious settlements. And this makes the whole difference when we are planning which kind of intervention we are going to make. So it comes with the previous comment as well. So how this data could be useful for the intervention. So one of the things that we are discussing here is first to try to scale down this national or state or sometimes municipal indicators into the local scale, so we can provide this deficit and inadequacy indicators, which are within those precarious settlements that then demand urbanization, upgrading strategy, and those that are outside the precarious settlements. So we are sometimes doing a spatial microsimulation of data. This is one strategy, so from such census data in different scales. Other strategy is to use these administrative registers that I mentioned about, that they haven't been explored in geographical scale, let's say in spatial scale. So we are also bringing into this direction. And the question now, how Earth observation can help, well, I think it's basically clear with all this presentation, but I saw one question here at the mirror. If this is enough as an indicator, then we have an issue, right? It helps when we don't have any data, so it's an indication. But of course, the shape doesn't answer everything. So we have much more to combine and to advance in this direction. And it's not easy, it's tough.
Thanks a lot. I would like now to call Juan Pablo, and maybe you have a question for Sophie. Are you with us, Juan Pablo?
Yeah, hello everyone. Yeah, well, actually, I have a question related also to the climate change. And beyond the urban heat that you already mentioned, in the case of Medellin, for instance, here in Colombia, the topography is very complex. So now I would like to know if you have explored the relationship between landslides, early warming systems, and the location of slums, for instance.
The question, I don't know if you, Sophie, feel comfortable, because I think you're more on the building mapping.
Yeah, I think the question does not directly go to me. No, I can just say one thing, that we in regards to climate data or climate change related to Itiquini, no, because in Itiquini, where we developed the tool of BEAM, the initial request was as well due to strong floodings to use the tool to see results before and after the flooding and which informal settlement got affected. But answering the question related to heat islands in Medellin, I think there are other people who shall go there.
But maybe we come back to the question of climate aspects, and maybe my colleague Ryan has a question on more the technical aspect of the work Sophie presented.
Yeah, hello everyone. Thanks, Monica. Yeah, I have some technical questions for Sophie. I had also some other questions more for the policy side, but I'll focus on the technical here. And Sophie, one thing that I was very interested in understanding on BEAM and on your work is which kind of AI models have you used? And if you have focused also on satellite images or only on aerial images. And also the reason behind my question is because we have, together with Monica and Claudio Percelo here, we have, and also with other researchers in our project, we have explored deep learning and other AI models focusing on open satellite images, specifically talking more about Sentinel-2. And one of the biggest problems we have when we come to that is the resolution, because mapping slums with 10 meters spatial resolution is quite a big challenge, because you don't have much details on the buildings and on the areas itself. So have you explored something in that sense? And which AI models have you explored for the work in general?
Mm-hmm. Yeah. So I'm as well not the expert on the technical level. So Mike is not here with me today, but we trained the model as a UR and HRNet model. And related to your question on satellite images, actually BEAM is currently trained on aerial images. BEAM is trained on aerial images for the city of Itiquini. So we only got, or till now, we could only secure good results in Itiquini because it's trained on those images. No, we tested it once with images in Dar es Salaam, but we have to further train it. In the new project that we have now with UN Habitat, we just contracted a data scientist a week ago to do the inventory on informal settlements in Central America. So there we will upgrade the whole BEAM application on satellite images. So happy to follow up on this regard and to discuss this in the future. But I just wanted to mention as well that digital tools, or I just have had digital tools on one hand are very, very important, no? But I think digital tools do not work, or if this knowledge is kept in silos. So it's not only about the perfect solution. I think it's rather about collaboration to set up transfer structures, multi-stakeholder research, and participatory processes. So I just wanted to add that we would like to work on the BEAM tool, not only detecting informal settlements, really bringing it into the community planning process and working with the community. And so what we did here was to have an advisory meeting and to involve as well community, NGOs, and different stakeholders. Yeah, but this just an addition, because I think it's not only data the solution.
Thanks a lot. And I have to apologize for those who had their hand up and maybe lowered it. So I would like really now to open it for the general audience. We have little time, but maybe for the presenters, if you can go to the mirror and answer the questions also directly in the mirror. I would give now the word to Red Lili. Sorry, Janky. Sorry for maybe totally mispronouncing your name. Please.
Yeah, thank you very much for the opportunity. Great presentation, Sophie. I just have a few questions. So BEAM, is it able to count the number of buildings that are actually automated? Because if it can do that, that would be very beneficial for us as planners, because then you can actually sort of determine what the population of that area is. And the next question is, how regularly are your aerial images updated and the automation process actually taking place? Because that would also be helpful for us planners in terms of tracking the population growth in that informal settlement, and allow us to devise the necessary instrument in order to, put in place a whole range of interventions. The next one is, are the cost implications associated with that BEAM, if a government department in another province would like to maybe appoint you and be involved, because I would have to convey this to my employer. But thanks, that was really a great presentation and great work. Well done.
Thanks a lot.
Yeah, related to the first question, yes, you can count the number of houses, because you can open the shapefiles in QGIS and then do the estimations, count the rooftops, see how many buildings are present in a given image. So this is possible with Itiquini, and they fly over the city once a year. So it's on a yearly base now. I think it needs to be, if you get satellite images, then you don't have this bottleneck of getting aerial images that you only get once a year, because it's super expensive as well to fly over a city. So I think there it's easier to update the model on a regular base, and yeah, happy to follow up on training the model as well for different cities.
I think we are now 1 minute over time, and I now just I was texting also. So please leave your contact details, and we will try to answer the questions. And there are so many questions and so many relevant questions in the mirror. We should have made this session at least half an hour longer, I suppose. But I would like to hand over now to Anthony for closing. Are you okay?
Yeah,
is there any
Thanks,
super
Monica.
burning question we should still answer? I know that Henry, you had also your hand up. I don't know if you want to make a very quick question before Anthony's wrapping up. And sorry for all those who have been staying there and without putting down their hand again.
Yeah, just Henry here. A quick thing when the question about data to solutions, I think one of the best things is in as much as we are hoping to use AI in some of these automated approaches, we also have to remember that engaging the community using citizen science is a very key component in understanding what the data that we are picking up is telling us. That is one of the best ways to be able to adequately translate or transform the data we have into information for solutions. That's the point I wanted to make.
Well, thank you very much. Also, well, I have a minute, as we're already over. We see that there's always the need for more time, so we will organize another webinar that will be really focusing on discussing, connecting to the ideas that were dropped here in former webinar. And this take place on the 14th of November at 1700 CET. If you want to stay in touch, either follow us on social media, because we will post this information, or the easiest way, fill out the very quick survey, so we have your email and can send you a reminder as soon as the program stands. Chat, you will see we have recorded this webinar also to make it accessible. It is not easy to time an event that interests fully, so therefore we have also recorded the webinar to make it more accessible. You have the social media channel on YouTube that it will be made online probably in 2-3 days. And that's it. So I thank all the presenters for sharing very interesting insights. I want to thank Monica and Julio also for a very professional moderation, and the participants for sitting through this time. I hope it was interesting for you. We are looking forward to the next event in next month. That's it.
Well, thanks a lot.
Thank you.
Thank you very much. Bye.
Bye-bye.
Thank you very much. Bye bye.
Thank you very much. Bye-bye.
Bye.
Bye, everyone.
Thanks for staying with us the whole time.
Thanks, Monica, for the invite.
And the planned date most likely is 14th of November, I think, for the next.
14 November, yeah.
Yes.
Okay.
Put it also in the chat.
Bye.
Bye bye. Thank you.
Bye.
Or shall we still stay very short in the meeting?
Yeah, let's drop the last picture. You can help me removing some people. Stephen was here. Fantastic. Move. What to go?
Maybe some people fell asleep if it's awkward time zone. I had it once in a in a webinar. Angela is now calling me. Sorry, because we have a follow-up meeting on another topic. Sorry.
You can stop. I can stop the recording. Yep.